analytics tools, cost of implementation, etc., it's far more expensive, right? The business case is also strong. So cloud computing is the way to go forward, at least in the beginning, and then you can take a call how you want to go about it. So, and then, big data, when you are doing so much, so mobility is a natural extension that, you have covered 90% of the distance, the final 10% is the mobility. So this is what I had to share, and I will be available at the TCS stall in case you want to have more conversations about, any of these areas. And incidentally, we are all also running the demos for mobility. So some of the solutions like sales and service, for these areas, we are running a demo. So I would welcome you guys to come and please join us at our stall. Thank you.
Thank you, Ritesh.
Thank you very much.
Thank you.
I would like to call upon our next speakers, Mr. Sanjay Mantri, Dr. Reddy's Lab, and Mr. Manish Kumar Singh from Siemens to give a presentation on energy management.
Good afternoon. Since morning, we have been listening to a lot of topics which are over-encompassing and will affect a large spectrum of what we all go through in our day-to-day life in manufacturing. Topic which I am presenting with my ex-colleague, Mr. Sanjay Mantri, is important. It is something which is happening now and has got more to do with nuts and bolts of what is impacting the industry. And why it is important? It's energy. It constitutes around 15 to 65% of the cost of manufacturing. It employs 10 to 30% of the manpower, and cost is expected to rise at 15% per year. In India, we are largely thermal-based energy generators, and our coal supply, we all know, is not keeping the pace with the requirement. Every year, we have a news starting with 15th of April till 15th of June that there is stock of only 7 days or 8 days with our power plants. So this is something which is important, which everybody is struggling. And I would like to deal with the macro scenario of energy in my presentation, and Sanjay would present a case study which he has implemented in his company. Now, what is energy and what is energy largely for manufacturing? It's divided into two parts. One is thermal and power. These are the primary source of energy. One is power, second is steam. Now, there is another angle to energy which is secondary: compressed air, chilled brine, chilled water, depending upon which kind of manufacturing plant we are operating. And once we think this part is normally a black box. We think we have a bill, we are giving X amount of rupees to the energy suppliers, and our total bill is X rupees. But do we really know who are the A, B, C category of consumers? What is the efficiency at which I am generating my secondary utilities? What is the efficiency at which the secondary utilities are coming back to me? Because the characteristic of most of the secondary utilities is that it comes back, and then you have to again do some addition to that and then again send it back to the consumers. So where am I and that's the most important thing for energy management. Once we have done all this, then you have two more areas. One is liquid effluents and solid effluents. As we go towards sustainability, and as one of the speakers prior to us spoke about, is that if you remove humans for in 6 months, the planet Earth would be much better in 25 years. So in order to keep our standing better in the environment, we need to look into the effluents which we generate. One of the things, like we are having 16% of the GDP from manufacturing, and if we want to go to 25% of the GDP, which would be 3 trillion by the end of 12th plan, it means that there will be a lot of effluents getting generated. These effluents are not really something which needs to be discarded. These effluents can itself be used as an energy source. So the gamut of energy management is not only in getting the power and using it, it deals with how you are using it, how you are generating the secondary utilities, and how we are dealing with the effluents. Now, as I said that I will be dealing with the more of a macro strategy of how we should be implementing energy management. First and foremost is bring transparency. If I am giving X rupees of bill per month to the utility suppliers, where that X rupees is going. So first and foremost is at the layer 0, we all know the famous model of automation. At layer 0, please put some measuring devices. Like most of the places, whether we admit or we don't admit, we do not have online devices, online measurement of devices. So first and foremost is put online measurement, develop capability, develop models to reflect what is the use of that data. So convert that data into information, identify the potential users, not only the operator who is going to operate utilities, but also the other people who are going to get affected by that, then visualizing it and then acting on it. Once we have done this, then we go back to the slide. Once we know that where the power is coming from, then it is important to deal with the black box. Who is using? Allocating the energy cost. Develop an SLAs for the utility suppliers within the manufacturing site. Who are my consumers? Who is using? For what purpose he is using? Energy cost per production unit, which will be real time, which can be available and which cannot be manipulated with, and then energy flow per production unit. So once we have these two things, then only we can look into optimization measures. Like we talk about a lot of things, condensate recovery, low grade heat recovery, producing steam by other alternative sources. But this is all is fine, but what was the zero? So unless we implement phase 1, we would not know where is the zero, and once you know where is the starting point, then only you can move forward. So phase 3 is more often moving forward. Once we have done the data, once we have data, once we know what this data means, then you get into the phase 3 in which you use many other things in order to improve that data. Now, I am getting another data that 3,000 megawatt of power was available in last 4 to 6 weeks in Tamil Nadu, and people did not know how to use it. One of the reasons why people do not know how to use it is lack of availability of arrangements. We are largely in AP for that matter. I worked here for last 3 years. In AP, everybody gets power from AP Transco. Now, there is also facility available by which you can get in agreement with independent power producers, and you can get power from them. It is not necessary that you always buy power from AP Genco, and AP Transco will inform you when would be the planned shutdowns. And if we have this kind of arrangement, which can be legal or managerial in nature, then you can use those 3000 megawatt which was available somewhere else, which will bring down your X rupees which you were giving as a power bill. It directly reduces the cost of energy. Second is, once we have done that, then you look into other source, heat. There are so many alternative sources of power. Instead of using coal as a main cost, use other things which are more environment friendly, which are available, which are renewable, does not cause lot of harm, and most importantly, does not call for lot of change in the equipment. If we are able to do these two things, then we will be able to have control over the input cost. Then the second step, as we discussed, would be getting into the energy planning. Now, energy planning you can do only if you know what was your production plan last year, how you produced, what is the forecast. So that's more complex, and that also has got something to do with your capability to have information about what would be the energy consumption per unit of production. So that's something which should be done in phase 2. And then once we have done these two things, then start reporting. Reporting is the most important aspect, because unless you report, as the last presenter said, unless you report, unless you analyze what you are doing, you will not be able to move forward. Now, how to reduce cost? Lot of thing has been already covered. One is, first and foremost, look into reducing the cost of procurement. If we are getting power from one source at this rate, we need to look into whether other alternative sources are available. Can we reduce that? What are the leverages I will get? What is the reliability of it? Second is reduce consumption. And that reduction in consumption can be done by two ways. One, you have data of energy consumption per production unit, and second is you are able to predict what would be your requirement at least next week. If we are able to do prediction, we will be able to do both, because we will be able to negotiate better with the utility suppliers, and we will be able to reduce the cost of production per unit. So this slide I will skip, because this will become more relevant once we see Sanjay's presentation. And with this, I would invite Sanjay Mantri, who is with Dr. Reddy's, has implemented many energy management initiatives. He has around 17 or 18 years of experience, and he has been working with energy management for last 7 to 8 years. So please welcome Sanjay Mantri.
Thank you. Good afternoon. As Manish said about it's quite imperative, looking at the numbers, what Manish said, that we are, before that, thanks ARC, I'm grateful to ARC and my automation partners for giving this opportunity to speak about. I'm also thankful to my management, because without their vision, we could not been here where we are now. We have been doing a lot of solutions. We have done a lot of automation projects in pharmaceutical space. We are the first company to implement MES, which is widely spoken about Andy, in pharmaceutical space of India. Now coming back to the numbers, what my colleague said, around 34%, 30 to 34% basically, there are two energy resources. One is primary and one is secondary. So in the primary factor, it goes around 30, 35%, 34% of the energy, and secondary is what about it's not working. So before going there, So it becomes very imperative that we should attack or we should work on a front which is very critical. Looking at the supply to demand ratio or gap in India, we need to work, and we worked on that. There are three parameters, three aspects on which we worked. One was basically to see that what are the equipments what we have to utilize or to optimize maximum. Second was to get that whatever the fuel energy cost is there, we need to see that this is been at the benchmarking stage. And third was to see that where we can improve on energy and fuel cost. So on the three aspects we started with. So coming back to the agenda, we have what was the objective which I said to you now. We had some issues before starting it, and then how it was achieved. We had some challenges also, the way every projects have. We have benefits and roadmap. So you see now, the right-hand side of the corner is basically what are the equipments. There are a lot of things, lot of utilities, primary, secondary, which is consuming a lot of energy. And we need to integrate to a one level so that the management of the left side sees it, and we make that available to management, or transparency is meant into it. So you can see that everything is basically at one level. That is what the aim was, which we achieved. What was the objective? Objective was to get the centralized monitoring of all the energy resources, utilities, optimization of all the fuel and energy, then healthiness monitoring of all equipments on a real-time basis, minimizing human intervention, because of which reliability issue was there, quality improvements, because with the help of this productivity, quality improvement which was the issue which we wanted to make the objective of it, and then benchmarking out of it. But but not the least is safety. Somebody said in the presentation that safety is a critical factor which we have also worked on. I'm not going to touch upon what is that system is going to talk about, what is that function. We wanted to make a single window system, and which we made by integrating all the equipments and utilities and BGs and all that. The features, they were basically to integrate all islands, changeovers, auto sharing, starting, auto operations, demand management, real-time monitoring, dashboards, and benchmarking. If you see the architecture, it takes you there where we wanted to go, and we reached there finally. You see on a top view, we have a management view that is basically for dashboards and all that, for even above that. Then we have basically divided into two sectors. One is for electrical parameters, DG management. On a lower side, we have basically divided to utility management. That depicts the picture. That depicts what we wanted to achieve. All the critical equipments which are taking the energy and giving a lot of opportunity for us to work on. It is basically integrated on architecture here. So we had issues about managing all operations. Though it actually, as I said earlier, that this is all islands of equipments and islands of operators were working on these islands of equipment. So it was very difficult to manage on this. From operation point of view, precise utilization of them, electrical point of view. Coming back to electrical point, we had, you see the condition of, somebody said that 2 months before there was a critical condition of power in India and especially in Andhra. So see how many interruptions we had. Because of interruptions, what is the productivity loss and quality loss. Then with that, what is the operation and maintenance cost which was going up. Then data recording, which was basically on manual basis, and nobody was used to get into it and then come to the conclusion that what is to be modified and required to be done. Benchmarking was an issue. We were not aware that which is the best equipment, which is giving the best value of or utilization or optimization. And safety, because of manual intervention, safety was an issue. As Manish said that we went in approach where with phase-wise approach, where we talked about getting into 3 pillars. One is to see that what is available, how to utilize that, how to integrate all level 0, level 1 instruments or PLCs to a system, see that all the parameters are covered there. At least we got, I'll share that what are the experience about it here. Then Then phase 2 was to allocate energy cost to all the users. They came to know about this cost once we given earlier. It was not on a paper and they were not aware of it. With the help of this, we actually got a transparency here now. On phase 3 is auto load management, or maybe your productivity or planning part of it, integrating with that, which we are in the phase of doing it. And then if we do all this, you really reach there where we want to reach, that is optimization. So how it was achieved? It was basically into a couple of phases. We have a planning phase. In fact, we had many phases here, but we are only talking about 2 phases here. One was a planning phase. It was to collate the requirements, and then vendor finalization, then to getting it to phase-wise approach. We cannot straight away go with the full bang theory. We should go with phase-wise. We started with the DG management on few DGs, and then went on getting all the DGs, and then went on taking on utility factors also, utility equipments also here. Also team formation. On implementation phase, I'll not talk about more what we did. What I will only say that we modified our equipments or electrical parts of it to integrate to our requirements or to integrate to our systems. We also added level 0 or instruments, level 0, 1 instruments, PLCs there to capture data on real-time basis. In fact, we also worked on a aspects where we thought in case this is becoming very critical, so why not also talk about making the redundancy at controller levels or power supply levels and all that. And one step ahead, we also wanted to go in case this stops. We should not come to the position where the plant is getting stopped because of this. So we wanted to go with local remotes, automatic, semi-automatic mode of operation, which we did. I'll not touch here what we did. I'll just say for a DG part or electrical grid part, we had 2 busbar system, SFU-based system to manual changeover system. And what we did is basically now making all automatic here with means getting out to single busbar. So we have achieved a lot of here. We have also made about synchronization here with grid to DG and grid to DG automatically. If you see on a chiller part or utility part, we integrated all the parameters from the equipment some parameters directly from the equipment, some parameters by adding some instruments at the sites or fields. If you see the slides here, it will tell you what we were missing on. On a front where you see the alarms management or the critical parameter monitoring, though all the equipments are scattered and the operator used to sit at the control room, it was difficult to manage everything. And sometime we also felt that the equipment was running at the higher critical zone and nobody was attending it. With this, we also added about some instruments like flow measurements for getting the efficiencies, COPs of chillers or compressors, by which we are getting now what is the COP or TR or efficiency of a chiller. By adding all this, we are now able to understand what is the requirement of a chiller or compressor or all for that, say, utilities. Then we are optimizing based on the need. We are not running all the equipment utilities as we were running earlier. Coming back to compressor, same. Earlier it was, for example, what is the loading pattern which was not known to anybody. Now with the help of this solution, we can know what is the loading and unloading pattern. And now we can know what are the leakages, where we have to improve on, which is giving a good transparency to us and by which we are attending it. On challenges, definitely challenges are when somebody is working on. There are a couple of challenges. One is operation and one is another challenges. On operation aspects, we wanted to get the running plant which was running and then equipments which were old, wanted to modify that to suit our requirement. That was a major challenge. Shutdown availability was a major challenge because running plant we cannot do, everybody's talking about the numbers. focus on short-term gun. Somebody said that we always work on the short term. We don't work on the long term. And that was a big challenge to change the mindset. Benchmarking figures were not available. What was the cost parameters, utility parameters, chiller parameters, KW parameter, TR parameters, COP parameters were not known to us on a real-time basis. Then integration with the equipments which were old, that was the challenge. I only mentioned few, there were many. On other sides, one of the challenge was mindset, management buy-in, to pick the right team, and involvement of a project members. Management buy-in, which I really thank to the management that they have pushed us to a level that we are talking about giving the presentation here. We did a lot of things and we achieved a lot of things. Here also we went to them about talking about this budget and they said they got their time and then finally they said go ahead with the pilot. So we did pilot successfully and then when we shown the numbers to them, they got really, they pushed us. They said that why not you implement as early as possible. That was an area where I felt very happy that the management is also buying it now. And with the help of this, this kinds of solution, we are now doing a lot of other automation and IT solutions in industry. I'll not talk about what are the benefits more. You see the quality improvements, then environment condition maintaining in time, and you know pharma industry, we need to maintain environment condition in time, otherwise the quality gets impacted and the product is to be thrown away. Elimination of penalty, MD penalties, then on a fuel aspects, I would say a couple of months back because of AP government state issues, by optimizing the resources, we have saved enormously. We have on a fuel. In fact, out of 12 DGs, we used to shut down 2 DGs or 3, in fact, some of the times. And you see the fuel cost, 180 liter or 190 liter per hour of a DG, and costing you see 40-41 rupees for 24 hours in a span of months, 12 days. You see what is the cost we are getting the benefit out of it. An operation point, single window system to work on, enabling quick decisions to act, to see that where improvements are there, where improvements can be done. Then the maintenance management, rather than going for haphazard way, going for unplanned way, we have a predictive kind of a maintenance which is been taken up now. More safeties, which is ultimately what we gained out of it. This is a pyramid which finally what we achieved is, I just wanted to showcase once again, from a bottom level, we integrated bottom to top. You see from bottom we modified our equipments, we added some instruments, we added some layers. Then on an operating control system, we gone for a SCADA and then tried to connect that and we ultimately succeeded in it. And finally on a management perspective, we given a dashboards, we have given a portal to them on which we can take the decision on and then we can work on and basically make the benchmarking for the next plant or next projects. That's what we achieved. Finally, some of the benefits on energy perspective, I have not gone into details, but we have said enormously here on directly on energy savings for switching off some pumps, fans, chillers, pumps, compressor. You see the cost of all electrical energy and indirect energy. So that is contributing much. We are in fact getting the benefit. If you see for this project, we got the benefit within 1 year. We got ROI within 1 year. That is what we achieved. By doing so, we also gone to a stage we are talking about getting into benchmark platform where we can integrate everything to a benchmark platform by giving some sort of portal where we can compare vis-a-vis between plant to plant. And then we can run on how energy can be utilized properly or how the cost can be made effectively and all that. So that is giving some real momentum to us by these kinds of solutions. Advantage I will not speak about. If we want to go for a system, you have to see that system is very rugged. You have to see that scalability